In 1980, 4 small foot bones were found in a box of animal fossils inside a storage room at a South African museum. They sat there for more than a decade, forgotten, mislabeled. No one paid them much attention. Then a paleoanthropologist named Ronald Clarke pulled them out and recognized something that nobody else had seen. Those weren't animal bones. They belonged to one of our oldest known ancestors. And the rest of the skeleton was still down there, buried inside a cave in Sterkfontein. What Clarke found over the next 20 years would change the story of human origins in South Africa forever. They called it Littlefoot. It is more than 90% complete. It is 3.67 million years old, and in late 2025 and early 2026, 2 new scientific studies revealed that almost everything we thought we knew about this skeleton may have been wrong from the very beginning. To understand what has just been discovered, you have to start with the cave. Sterkfontein is located about 25 miles northwest of Johannesburg, in a region of South Africa known as the Cradle of Humankind. It is a UNESCO World Heritage Site, and it has produced some of the most important early human fossils ever found. Australopithecus africanus was first identified there. Homo naledi was discovered nearby. The region has yielded dozens of skulls, jaws, and partial skeletons going back more than 3 million years. When Ronald Clarke identified the 4 small ankle bones, he believed they belonged to an Australopithecus. In 1997, he led a team back into the cave to search for the rest of the skeleton. What they found was extraordinary. A nearly complete fossil partially embedded in the wall of the cave, locked inside a hard sediment called breccia. Excavating it took 20 years. Clarke and his assistants had to painstakingly chip the bones out of the rock, working millimeter by millimeter while the skeleton remained anchored to the cave wall. The final visible pieces weren't removed until 2012. The cleaning and reconstruction continued for years after that. By the time the fossil was finally unveiled to the world in 2017, it had become the most complete Australopithecus skeleton ever discovered. More than 90% of the skeleton was preserved. By comparison, the famous Lucy skeleton from Ethiopia, which dates to 3.2 million years ago, is only about 40% complete. But the moment Littlefoot was unveiled, an argument began. Clarke believed it was a member of a species called Australopithecus prometheus, a name first proposed back in 1948 by an anatomist named Raymond Dart. The species had remained obscure for decades, but Clarke argued that Littlefoot fit it precisely. Most other researchers disagreed. They said Littlefoot belonged to Australopithecus africanus, the more familiar species first described by Dart in 1925. There were only 2 species at Sterkfontein, they argued, and Littlefoot was simply an older example of one already known. That argument went on for years. And then, in late 2025, a third possibility emerged. In November of 2025, a team led by Jesse Martin of La Trobe University and the University of Cambridge published a study in the American Journal of Biological Anthropology. The title was direct. The STW 573 Littlefoot fossil should not be attributed to Australopithecus prometheus. The researchers used 3-dimensional scanning to compare Littlefoot directly to the type specimen of Australopithecus prometheus, a skull catalogued as MLD1. Both fossils were digitally captured at a resolution of 300 micrometers, fine enough to map every contour of bone surface. What the comparison showed was striking. Littlefoot and MLD1 shared no unique combination of features. The team identified at least 5 anatomical differences in the back of the skull alone: the shape of the parietals, the configuration of the ridges where the temporal muscles attached, the structure at the rear of the head known as the external occipital protuberance. The 2 fossils, the researchers concluded, simply did not match. But the team went one step further. They argued that MLD1 itself did not differ in any meaningful way from known specimens of Australopithecus africanus. In other words, Australopithecus prometheus, the species Clarke had used to name Littlefoot, may not even be a real species. It was, in their view, just an older sample of africanus that should never have been separated in the first place. So if Littlefoot was not Prometheus and not Africanus, then what was it? The team's answer was cautious. They argued Littlefoot does not match either species, and that it is most likely a previously unidentified human relative. They did not name a new species themselves. That honor, they wrote, should be reserved for Ronald Clarke and his colleagues who spent decades working with the fossil. But the implication was clear. The skeleton everyone has been looking at since 2017 may belong to a branch of the human family tree that nobody has ever recognized. And Sterkfontein, the team noted, may have held not one but two distinct hominin species living side by side, just as Clarke had argued from the start. The next study to come out would only deepen that question. 4 months later, in March of 2026, a separate international team revealed something even more visceral. They showed the world what Littlefoot's face actually looked like. The study, published in the journal Comptes Rendus Palevol, was led by Amélie Baudet, a paleoanthropologist at the French National Centre for Scientific Research, and Dominic Stratford of the University of the Witwatersrand. It had taken more than 5 years to complete. The challenge was that Littlefoot's skull had been crushed during fossilization. The weight of the sediment had shifted, fractured, and distorted the bones over millions of years. Physical reconstruction was impossible. Every attempt to glue the fragments back together would only lock in the distortion. The team needed a way to take the skull apart and put it back together without ever touching it. So they flew the skull to England, specifically to a facility called Diamond Light Source, a synchrotron at the Harwell Science and Innovation Campus in Oxfordshire. There, the team used a powerful X-ray beamline called I-12 to capture detailed internal scans of the fossil slice by slice without damaging it. The resulting model reached a resolution of 21 microns. That is finer than the diameter of a single human hair. The team then used supercomputers to digitally isolate each broken fragment, correct its position, and rebuild the face piece by piece. The result was the most complete face of any Australopithecus specimen ever produced. And here's where the story collides with the species debate. When the team compared Littlefoot's reconstructed face to 3 other Australopithecus specimens, one from South Africa and 2 from Ethiopia, they found something unexpected. Littlefoot did not look like the South African comparison. The size of the face, the shape of the eye sockets, the overall facial architecture, all of it more closely resembled the East African specimens. That suggested something profound. Littlefoot may have shared ancestors with hominins from East Africa rather than with the later Australopithecus africanus population of South Africa, a migration, a movement of an early hominin lineage traveling across the African continent more than 3.5 million years ago, long before any of our direct ancestors emerged. 2 studies, 4 months apart, both pointing at the same conclusion. The skeleton everyone has known as Australopithecus prometheus may not be that species at all. It may be something nobody has ever named, with deep ties to East Africa rather than the southern population it was buried with. For nearly 3 decades, Ronald Clarke insisted that Sterkfontein held 2 different hominin species. He may turn out to be right, just not in the way anyone expected. If you want to see the moment ancient bones rewrite the human family tree, subscribe to Origins Revealed. The next story is already coming.